For this video, I will tell you on how to differentiate these three cases. The first case that I want to discuss about is actually you are given a charge moving parallel to the field. For example, initially this charge at here, okay, since the charge we put in the electric field because it is in between the plate. So we can say the charge actually in the electric field. Then the charge always experience electric force. Okay, electric force. So means for Y component there is electric force. So I write here for Y component we have Fe here. Then we try to predict where is the direction for the electric force. So as I told you before, the direction for the electric field always from positive towards negative. So this one is a direction for the electric field. And since this one negative charge, and what method we are using to determine the direction for the force. So I'm going to use the equation F equals to QE. This one negative charge, so I will substitute Q with negative. So from here I found that the direction for the force and electric field always opposite. Okay, always opposite means if the direction for the E downward, so it should be upwards. So I found that Fe upwards. Okay. So where is your direction for acceleration? If your Fe upwards, your acceleration will also follow the same direction. Okay, so mean this particle will going up. So usually for this case, you will be given a charge which is the mass can be negligible, so that the only acting force on the charge is actually electric force only. Okay, then your charge can move parallelly. Yeah? So if your charge move parallelly, so means that there is no motion at all along x component, right? So means any equation which is along x component actually not related with this case. But how about this one? Okay, so as I told you before, in this question, charge moving perpendicularly to the field. Perpendicularly means, okay, move means the direction for the V. Perpendicular means 90 degrees to the field. Field here means electric field. So look at here, where is the direction for the electric field? Always from positive towards negative. So if you measure the angle between V and E, among 90 degrees. So for this motion, actually there are two possible for your case. Means what will be different of this one? Okay. In order to achieve dynamic equilibrium, means in order for the negative charge to move undeflected along the way here, you found that this charge should acting by two force, where these two force with the same magnitude, right? Jadi kalau pergerakan contohnya negative charge ini adalah tanpa pesongan, then is under this case. But for the charge under this case, you found that there should be two forces which is same magnitude, and then they should acting in opposite direction. Only the negative charge can travel undeflected here. So in this case, again, you tengok for this case, untuk komponen Y saya dapati untuk kita kira resultant force-nya. Okay. I found that resultant force, kalau kita kira, dia sama juga dengan kalau force ke atas, Fe, force ke bawah minus, if they are with the same magnitude, for example 500, this one 500, so you get 0 here. So the equation that you can get here, you found that is actually Fe actually equals to W. And what is the equation for weight? Weight actually equals to mg. Okay. And what is the equation for the electric force? I will found that it's actually equals to QE. So here will be important formula for y component. Okay. And for x component, okay, memang gerakan dia pada component x, but memandangkan dia mencapai apa yang kita panggil dynamic equilibrium means that, okay, dynamic equilibrium means is actually moving with constant velocity, so means the resultant force for x component 0. Okay, so this one is for this case. Okay, both of this case also we have a charge which is moving perpendicular to the field, but for this one, okay, I will tell you what is the differences between these two. Okay, I will found that for this one, usually the weight for the particle here is actually negligible. Maksudnya berat dia boleh diabaikan. For example, electron. The mass for the electron is so small, 9.11 power of negative 31 kilogram is so small, so we can negate the weight. So when a negative charge in the electric field, then there will be electric force, right? So what is the direction for the electric force? If this one electron, negative charge, the direction for electric force always opposite to this one, right? Opposite means kalau ini ke bawah, maksudnya ini akan ke atas lah. Fe kita ke atas. Dan memandangkan tak ada berat, kalau Fe ke atas maksudnya percutan pun ke atas. A pun ke atas. Jadi kalau A pun ke atas, okay, so your negative charge will deflect towards positive plate. Alright, so in this case, for y component, I will found that the only force that acting on the electron, I will found that is actually, if you look at here, Fe only. Jadi memandangkan hanya electric force yang bertindak ke atas charge tersebut, then it's actually obey Newton's second law. Okay, ini net force dia. And what is the equation for the net for the electric force? F actually equals to QE. I'm going to find A. A actually equals to QE dy by M. Okay, so this one is ini adalah equation penting bagi A. Dan untuk ini, untuk X component pula macam mana? Memang arah V bagi X component ada kan? Tapi pada X component tak ada apa-apa force yang bertindak ke atas electron kan? So means that resultant force for X component in this case, I will find that 0. Okay? Kalau resultant force 0, dengan kata lain A also 0 here. Okay? And this one with the parabolic shape. So for example, if you are given a situation where you need to find what is the time for the electron taken from here and then reach here? What is the time needed? So in order to find time, so you have to make use of, since this one parabolic shape, you have to make use of what you learned before, which is, still remember, for horizontal projectile. Okay, for horizontal projectile, okay, kita mesti ada komponen X dan Y kan. Dan you ada SU, ingat lagi you selalu list down SUVAT kan. And SUVAT for Y component kan. You selalu list down ini kan. Dan bagi horizontal projectile, Uy always equals to 0 kan. So we can apply this motion in this problem as well. Okay. Before this A always influenced by gravity kan. But our A in this case will be this. Okay. We substitute in the value here and Ax memang kosong. Ax kosong. Okay. So you can apply what we learned, which is in horizontal projectile motion. How about this? This one, macam mana pergerakan elektron ini dalam garisan lurus kan? So, for example, if I want to find the time for the negative charge from here until here, so what do I do? Saya pun boleh guna kinematics equation. Tapi hanya melibatkan komponen Y sahajalah. Okay, tapi hanya melibatkan komponen Y sahaja. Okay, but before that, see saya perlu selesaikan ni dulu. So in this case, okay, and see how I'm going to complete this. Okay, I will found that for component Y, since only electric force acting on the charge, so we use Newton's second law. Total F equals to ma. The only force contribute to the net force is actually electric force, so I have this one. And then electric force I can rewrite as F equals to QE. So how I'm going to find A actually equals to QE divided by M. Okay. Jadi kalau you dah ada nilai A, okay, ingat untuk ini, untuk case ini X, any equation relate to X, tak berkait langsung okay. Jadi untuk kita guna kinematics equation in a straight line, so you just list down SUVAT. Okay. Nilai A ni macam mana? Nilai ni. Okay. Nilai ni. Alright. So that's how we solve problem about this. So I will found that untuk case ini memang X tak berkait langsung untuk ini, tapi untuk Y, kalau you tengok persamaan ini dengan ini, persamaan dia sama. Because for these two, okay, the only force acting on the charge is actually just electric force. Okay. Dan untuk case ini, kenapa bagi komponen X, kenapa resultant force equals to 0? Because along X component, we found that tak ada pun apa-apa force pada X component yang bertindak ke atas negative charge ini. Okay, so that's why you have this. And for charge in dynamic equilibrium, you kena dapati ada beza dari segi equationnya. Okay. Ini A dia kosong, A dia kosong sebab nilai force ke atas balance dengan ke bawah. So you have this. Alright, jadi untuk hari ini sampai sini je.